Chapter 7 is about similarity. Section 7.1 is properties of proportions, and this is kind of like a review of Algebra 1. And these are skills that we need in able to solve proportions, because when we have similar figures, we end up with proportions. So first of all, what is a ratio? That's just a comparison of two things. So if I say that the ratio of boys to girls in here is 3 to 2, I would write 3 to 2. If I said, well, let's just go with that. That could also be written as 3 to 2. That could also be written as 3 to 2. So there's 1, 2, 3 different ways to write this ratio. Semicolon, with the word 2, or as a fraction. What's the ratio of female students to male students? If we said that this was 11 to 7, that means that there are 11 females that came first. Males came second. So we got female on top and male on bottom. The order does matter. The idea that comes first would be on top. The idea that comes second would be on bottom. If we said, what's the ratio of Twinkie riders to car riders in this class? And let's say that that was 3 to 8. That means 3 people are riding the bus for every 8 people that are riding in a car. How many people are we talking about there? We're talking about 11 as far as the ratio goes, but maybe there's 22 people, or 33, or 44, or 88. If you take the number of people and write it as a fraction and you reduce it, it's going to reduce to 3/8. Proportion. It's an equation. Equation has an equal sign. These ratios don't have equal signs, stating that two ratios are equal. So if I said 4 is to 8 as 1 is to 2, that's a proportion. Solve each proportion. We are using algebra to do this. So any rules that you know from algebra can be applied to these problems. For example, if you recognize that a fraction could be reduced, maybe you should reduce it. You're going to get smaller numbers. So for example, here on the right side of the equation, we can divide both 8 and 30 by 4. Another way to think of it is we're multiplying the fraction by 1 in the form of 1/4 over 1/4. I don't really care how you think of it, but if we divide, I take that back. We can't divide 30 by 4. We can divide them both by 2. If I divide 8 by 2, we get 4. If I divide 30 by 2, we get 15. So now we got x 12 equals 4/15. I am trying to get x by itself. Right now I'm dividing x by 12, so I'm going to multiply both sides by 12. On the left, the 12's cancel, so I have x. On the right, we got 4 divided by 15 times 12. If you like, you can put the 12 over 1. Can you think of a number that goes into both 15 and 12 evenly? 3. 3 goes into 12 4 times. 3 goes into 15 5 times. Now if you multiply the tops and you multiply the bottoms, you get 6/15. This cannot be reduced, so we can leave it right like that. If you didn't do all this reducing stuff and you just started out like this, which is fine if you do, and you multiply both sides by 12, which you have that option. The 12's cancel on the left, you have x equals 12 times 8, I believe that's 96. Now, this is the same answer as 16/5, but it's not reduced. So, for example, you could divide top bottom by 2. That would give us 48 over 15. Then divide the top and bottom by 3. And that would give us 16/5. I'm not great with numbers, So I would recommend reducing as you go instead of multiplying and reducing at the end. Number 12, number 2. Does this fraction reduce? No. Does this fraction reduce? No, it does not. So I want to get the x by itself, and unlike the previous problem, x is not in the numerator. So what I'm going to do is I'm going to get rid of the fractions that are in this problem because I don't want fractions in this problem. How do I get rid of this divided by 9? Well, I multiply each term in the problem by 9. There are 2 terms. That would cancel this 9 and this 9. I've got a problem on the right. I have a fraction. The denominator is an x plus 2. I'm going to multiply each term, there are 2 terms, by x plus 2. That cancels the x plus 2 on the right. So what are we left with? On the left, we have a 10 times an x plus 2. On the right, we have a 30 times 9. If we simplify this and distribute, we get 10x plus 20. On the right, 30 times 9 is 270. If we subtract 20 from both sides, we get 10x is 250. And if we divide both sides by 10, we're going to get x is 25. You can always check your answers, by plugging this 25 in up here. Is 30 over 27 the same as 10 over 9? You bet your bottom dollar it is. Number 3. I want to get rid of my fractions, so I'm going to multiply both sides by 10 and 3. Why 10 and 3? Because if you multiply both sides by 10, the fractions on the left cancel. If you multiply both sides by 3, the denominators on the right cancel. That leaves us with 3 times the sum of x and 6 equals 10 times the difference of 2x and 5. Now we don't have any fractions. Distribute the 3, we get 3x plus 18. Distribute the 10, we get 20x minus 50. If we subtract 3x from both sides, if we add 50 to both sides, if we divide both sides by 17, we get x is 4. Yay! Number 4. We could, let me tell you what I would do for this one. Could get rid of our fractions completely, or we could just focus on the fact that we want to get x by itself, so we want to get rid of this 9 here on the bottom. I'm going to multiply both sides by 9. So what does that do for us? You know what? I'm going to take a step back from that. Let's go backwards. This fraction reduces. This is the same as 1/3. It's the same as 1/3 because we could divide the top and bottom by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And then now let's get rid of the denominator on the left to get x by itself. Multiply both sides by 9. On the left, we get 7 minus x. On the right, 3 goes into 9 3 times. We have eliminated that fraction as well. Pretty fancy. If we subtract 7 from both sides, then divide both sides by -1, we get x is 4. Yahtzee. Number 5. Word problems can be intimidating, but if you look for clues in the problem, it tells you exactly what to do. On a bike, the ratio. Now when it says the ratio, it's going to give you a ratio. The ratio of the number of rear sprocket teeth, which we're going to call number of rear sprocket teeth for short, to the, that to the is really important. The to the signifies that we are done with the numerator and we're now talking about the denominator. Number of front sprocket teeth, let's write that down right now. So we have a ratio. It's the number of rear sprocket teeth to the fraction bar, number of front sprocket teeth. Is equivalent to, well, that's a dead giveaway, equal sign. The number of rear sprocket wheel revolutions to the tells us our fraction is breaking. So we got number of rear sprocket wheel revolutions. That is a mouthful, so we're just going to use the first letter. To the fraction bar, number of pedal revolutions. Number of pedal revolutions. Once that work is done, this is going to be easy. If there are 8 rear sprocket teeth, where am I going to put 8? Am I going to put it in place of rear sprocket teeth, front sprocket teeth, rear sprocket wheel revolutions, or pedal revolutions? Well, it says rear sprocket teeth, so it goes up here like so. 18 front sprocket teeth, well, that's the denominator on the left. How many revolutions of the rear sprocket wheel, variable, we don't know, will occur for 5 revolutions of the pedal? That goes right here. See, if you do your work here, where you just take your time and translate stuff into math, the problem does itself. It's like one of those Roombas. That thing just sweeps the floor on its own. It's just possessed or something. Here on the left, we can reduce the fraction. We can divide top and bottom by 2 and get 4/9. Trying to get x by itself, we could multiply both sides by 5. On the left, we got 5 times 4, which is 20, over 9. On the right, the 5's cancel, and we have x. The question doesn't ask for x. The question says how many revolutions of the rear sprocket wheel? There will be 20/9 revolutions of the rear sprocket wheel. Word problems earn a sentence answer. Number 6. One way to determine the strength of a bank is to calculate its capital to assets. This is a ratio, noted by the word ratio, as a percent. So the strength is to calculate the capital to, make sure that when you're abbreviating, you abbreviate wisely. Otherwise, you're going to get yourself in trouble. Capital to assets. Now it says as a percent. If you divide two numbers like these, you're going to end up with something that's not a percent. To change it to a percent, we're going to have to multiply this by 100. And that's going to give us a percent. A weak bank has a ratio less than 4%. So I'm going to write that down. Weak is less than 4%. The Jnatan National Bank has a capital. So let's look at the strength. Has a capital of 177,000, assets of 4,450,000. We're going to multiply this by 100%. Is it a weak bank? Well, some things we can do without a calculator. We can divide the top and bottom by 1,000, gets rid of those decimals. If you then throw this into your calculator, this ends up being 0.0398, and then this is times 100%, which moves the decimal place 2 places to the left, so that's 3.98. The strength is 3.98%. Question was, is it a weak bank? And to explain. And we would say, Jnatan National Bank is a weak bank because its strength is less than 4%. It's 3.98%. Got it? Number 7. The ratio, this is my favorite one, because this is one I could see me putting on a test. I'll see me putting number 8 on a test as well. But number 7, the ratio of the measures of the angles of a triangle is 3 to 5 to 7. Well, let's draw ourselves a triangle, boys and girls, because we don't know what to do. What is the measure of each angle in the triangle? So let me just give you a big picture thing here. Is it possible that not only are the ratios of the angles 3 to 5 to 7, but the actual angles are 3, 5, and 7? No, that's impossible, because 3 plus 7 plus 5 is 15, and the sum of the angles in a triangle has to be 180. So this couldn't be the numbers. But don't draw this. But what if instead of 3, 5, and 15, it was double that? So it was 6, 10, and 14. Could that be what the angles are? No, that doesn't have the 180 either. What if it's triple it? If it's triple the original numbers, it's 9 and 15 and 21. Doesn't have the 180 either. Here's what we do know, though. Point I'm trying to make. If we take some number, x, and multiply it by 3, 5, and 7, that number would be the missing number that we need here to tell us how much bigger these numbers need to be. It's called a scale factor. We will learn about that in depth as we continue. But a scale factor is how much bigger something is than something else. So we are saying that each of these are 3 times the same number. I'm sorry, it is 3, 5, and 7 times the same number. So what does that do for us? If we add the sums of the angles, it always equals 180. That's the angle sum theorem, also known as the triangle sum theorem. That's going to be 15x is 180, x is 12. Once again, what's x equals 12 mean? It means the triangle we're looking for is 12 times bigger than the 3, 5, 7 triangle. What's the measure of each angle? Well, one of the angles we're saying is 3x. That's 3 times 12. That's 36. Another angle is 5 times x. That's 5 times 12, which is 60. The other one is 7 times x, which is 7 times 12, which is 84. The angles are 36 degrees, 60 degrees, and 84 degrees. Dunsies. Number 8. I like this one for a test as well. Not as well as I like 7, but I like this one as well. On a map, 3/4 of an inch represents 15 miles. Let's write that down as a ratio. 3/4 of an inch represents 15 miles. Do you think 3/4 of an inch is 3/4 of an inch in real life or 3/4 of an inch on a map? It's a map. Do you think 15 miles represents 15 miles on a map? That's a big map. Or 15 miles in real life? This is an RL, people. If it is approximately 10 inches from Sandusky to Cambridge, now is that 10 inches on a map or 10 inches in real life? That's 10 inches on a map. Let me make sure this is clear, that it's not 10 in map, it's inches. What is the actual distance in miles? So what is the distance in miles? And this is in RL, in real life. Solving this little fella, we could multiply both sides by 15 and x. Cancels the x's on the right, cancels 15's on the left. It's going to give us 3/4 x on the left and 150 on the right. Oh, we still got fractions. Let's multiply both sides by 4. On the left, the 4's cancel. We get 3x. On the right, we're going to get 600. If we then divide both sides by 3, we're going to get x is 200. I say 200 so weirdly because I had something different written on my paper, which doesn't really make a lot of sense, but let's go ahead and go with 200. So answer the question, what's the actual distance in miles from Sandusky to Cambridge? It is, I don't know if this is actually right, by the way, I just made up the problem. It is 200 miles from Sandusky to Cambridge. All right, that concludes the notes. Your homework would be section 7.1 in the homework.